Let's look at how rods and cones are distributed in the retina. Let me begin by drawing a very simplified diagram of the eyeball. So in the back of the eye, we have the optic nerve exiting and going towards the brain. The back of the eyeball is coated by a specialized membrane known as the retina. This dimpled portion of the retina is known as the fovea. And the part of the retina directly in front of where the optic nerve exits the back of the eye is actually known as the blind spot. This is known as the blind spot because no photoreceptors are present in this area. Let's go ahead and look at the distribution of rods and cones in the eye. So rods are mainly found in the periphery of the eyeball. So we're going to use this blue color to represent rods. And they're found mostly in the periphery of the eye, so up here and a little bit over here. And as I mentioned, there are no photoreceptors at the blind spot because that's where the optic nerve actually exits the eye. So there's no photoreceptors there. Cones, on the other hand, which we'll represent in purple, are actually found throughout the fovea. So they're found in a really high concentration near the fovea. And there are no cones at the blind spot, and there are very few cones kind of sprinkled throughout the rest of the eye. So they're found kind of sprinkled throughout the periphery of the eye. So let's go ahead and zoom in on the fovea just to kind of make sense of what we're looking at. So if we zoomed in on the fovea, what we would see would be the retina, so it dimples in at the region where the fovea is. This region from here to here is the fovea. So let's go ahead and draw in the rods and cones. So rods are found, as I mentioned, outside of the fovea. So there are a whole bunch of rods in the eye, specifically in the periphery. So outside of the fovea, there are a whole bunch of rods. And there are more rods over here, and they kind of line the periphery of the eye, and so on. Cones, on the other hand, are found in a really high concentration near the fovea. So at the fovea, there are a whole bunch of cones. And in the periphery of the eye, there might be a few cones every now and then. So the reason that the fovea actually dimples in here is because these photoreceptors are connected to other neurons that actually send axons through the optic nerve into the brain. So there are a whole bunch of neurons over here in this region, and they all have axons that actually go to the optic nerve and exit the back of the eye. And so when light enters the eye and hits the fovea, what it actually looks like is like this. And so the benefit of having no axons in the way of the light is that you actually get a higher resolution. So you actually get more light is able to hit the cones rather than get absorbed by these axons. So if light were to enter this way and hit the periphery of the eye, what you would have light entering. It would actually have to go through this bundle of axons. And as it's going through, some of the energy is actually lost. So less light actually hits rods and cones in the periphery. So at the fovea, you actually have light directly hitting the cones rather than having to go through a layer of axons and neurons. So let's look at this same picture in another way. Let's go ahead and look at it graphically. So if I were to draw a graph, and if I were to say that the 0 point on the graph, so let's go ahead and this is the x-axis, this is the y-axis, and the 0 point is going to be where the fovea is. So if we were to actually take the retina, so in the eyeball, the retina is curved like this, and if we were to actually flatten it out, there's a little dimpled region here that's known as the fovea, and we're going to set this to 0. And then you can move away, so this could be 5 degrees away from the fovea, this could be 10 degrees away from the fovea, this is 15, and so on both ends. So that's what we're going to do here. So this is going to be 5 degrees away from the fovea, this is 10 degrees, and so on. And we're going to have the same thing on the other side of the fovea as well. So now on the y-axis, what we're going to have is receptor density. So this is the number of receptors found in the retina. So over here we have a low receptor density, and over here we have a high receptor density. So as I mentioned, this region right here is the fovea. And this outside region from here to here and from here to here is the periphery. So in the periphery, there's a really high level of rods. And then as we get towards the fovea, the rods drop in numbers. And then as we start to move away from the fovea again, there's a really high number of rods. And we actually reach a region which is the blind spot. So as I mentioned, there are no photoreceptors where the blind spot is. And then as we get to the other side of the blind spot, there are, again, photoreceptors. And so you kind of get this type of distribution of rods. Cones have a different distribution. So cones, there aren't very many of them in the periphery. But when you get to the fovea, there's a huge spike in the number of cones. And then as you, again, move away from the fovea, the cones actually drop back down. And then at the blind spot, there are no photoreceptors. And on the other side of the blind spot, there's a very low number of photoreceptors.